Thanks to all of you for joining us today. Our webinar topic is The Secret to Unstoppable Performance. Our goal is to help you learn how to ensure your system is performing at its best. Here at Donaldson Company, we've been solving customers' complex filtration challenges for over 100 years. We were founded in 1915 by Frank Donaldson Sr., who invented the world's first filter for a tractor engine. Today, we're one of the largest providers of unique filtration technologies, and we excel at producing high-quality filters and equipment. We pride ourselves in having a global reach with a local touch. Our world headquarters is in Bloomington, Minnesota. We have 56 manufacturing plants and 22 distribution centers around the world. Before we get too far into this, just wanted to give you a heads up that we'll conduct a live Q&A session towards the end of the webinar. As you think of questions throughout as we go, please feel free to type them into the chat box and we'll address them at the end of the session. And then during our webinar, our speakers, Alex and Taylor, are going to ask you a few questions and you can respond with a reaction emoji. All right, so pay attention to when they ask you some stuff. You can access those by clicking on the face icon at the bottom of the screen. All right, and with that, I'm pleased to introduce our featured speakers today. We have Alex Bozier and Taylor Campa. Alex is an aftermarket sales manager for Donaldson. He works out of our corporate office in Minnesota, where he told me they just got snow over the weekend. Kind of crazy. I'm in Phoenix, so that's kind of shocking to think. Alex holds a Bachelor of Science in Automotive Engineering Technology from Minnesota State University at Mankato, and he's been part of our aftermarket sales group for the past 9 years.
Thank you, Amy. I'm happy to be presenting and glad you could all join us today.
And Taylor is an application engineer at Donaldson, also working out of our corporate office in Minnesota. His role focuses on helping customers with technical and application guidance specific to the dust collection industry. Taylor holds a Bachelor of Science in Mechanical Engineering from North Dakota State University and has been with our applications group for about 5 years now.
Thanks, Amy. It's a pleasure to be here. All right, we'd first like to start out by asking about your experience with dust collection. Please select the emoji that best aligns with your experience level.
All right, we've got a little experience, but a lot to learn. Any other you guys find in those emojis? Feel free to react, no wrong answers. Some experience, some very specific questions, very new. Oh, we've got some experience, curious what else they can learn. So kind of across the board, but yeah, hopefully there's something in it for everyone today.
Yeah, looks like a good mix. Well, thank you, everyone. It's helpful for us to know the experience level of the group as we are getting started. So let's start out by talking about what could happen if your dust collector system isn't performing at its best. You might experience high operating and maintenance costs. You're likely going to be changing out filters, fan wheels, or other components far more often than you need to. You could also experience increased shutdowns and downtime, which is expensive, especially when it unexpectedly halts production. Production process failures can also occur, and different processes can rely on dust collection, like a laser table or blast booth that are interconnected with each other. So if the collector goes down, so does that process, and then everything else is halted because of that. Lastly, and most important, is the health and safety risk to the employees of the plant. You want to make sure to keep employees protected from dangerous dust and fume. Like, unfortunately, this guy in the well booth on the right, the system clearly isn't working well. So unfortunately, he is now subject to those harmful fumes. So it's definitely something we want to get fixed. Now, let's talk about how to make sure those things don't happen. The first secret to unstoppable performance is understanding how your system was originally designed to perform. It can be very hard to troubleshoot, make changes to, or gauge performance if you don't know how the system was originally designed. Knowing the baseline airflow, static pressure, and conveying velocity are all important for your system design. Next, what are the main components of your dust collector system and how do they operate? These could be airlocks, fans, dampers, no return valves. The picture on the left is a great example of this, with various different pieces of equipment all interconnected, and is really important to understand what you have. Finally, what does good look and sound like? Are we getting the proper suction and capture of the hoods, for example? Or are you starting to see dust buildup around your work area? Is there any dust bypass happening on the fan discharge? Can you see it, in visible daylight? Is the collector pulsing normally, or does it sound weak or like it's leaking? Does the fan have an odd vibration or sound out of balance? Is the airlock squealing or making odd noises? Knowing the baseline of your system will help you navigate the upset conditions, which we'll touch on later on in the presentation. Before we dig too deep, let's take a quick look at the basic components of a dust collector system. So here's an animation of a typical dust collection system. A blower or a fan creates an airflow, which is used to capture dirty air with a hood or other pickup. It'll then convey this material through a series of ducts to a dust collector. Here, the contaminant is separated out with the filter media, and the clean air passes back through the fan and then is discharged to the atmosphere or returned back into the building. Now, over the life of a system, growth and additions are common, and it's important to anticipate and plan for these changes to ensure that the system performance isn't impacted. For example, on this slide, if the system was originally designed with only hood number 1, we are looking at adding hood number 2, we need to understand the impact adding the hood could have on the rest of the system, like increased static pressure or increased need for more airflow. Or maybe this hood is a spark generating process. Do we need to add a spark cooler or other extinguishing agents? These are all going to have an impact on your system. All right, here is a real example of a dust collection system. This one is for a robotic weld cell. You can see 5 main components listed here. The fan at the top with a silencer for noise reduction. The dust collector, this one is a DFE cartridge collector. The ductwork, the hood, and the electrical controls. Now, some keen eyes out there may have seen the items circled now. These are a few safety devices. This one is a spark trap or spark cooler and a fire suppression system. So now that we've talked about system components, let's review some basic terminology. The most basic and widely applied formula is Q equals VA. Q is the volume of air flowing through the system, often referred to as CFM or cubic feet per minute. V is the velocity, which is the linear speed for an object in feet per minute. A is the area the air is flowing through in square feet. This is usually the cross-sectional area of the ductwork. Now, to get the airflow, we simply multiply the velocity of air by the cross-sectional area. So, part of understanding your overall system is knowing the design airflow and making sure it's achieving that. For example, if the system was designed for 3,000 CFM and it's only achieving 1,500 CFM, it could lead to serious issues such as dust buildup in the ductwork and decreased capture at the hoods, which unfortunately could lead to increased contaminant levels in the work areas. Now at this time, I want to pass it back to Alex to go over some other important terms we used in dust collection.
Yes, thank you, Taylor. One of the most critical measurements of an operating dust collector is differential pressure drop, or delta P. This essentially tells us the condition of the filters. It's the measurement in static pressure or resistance between the clean and the dirty side of the filter. It's measured in inches of water and is commonly referred to as water gauge or water column. In case you're wondering, pressure drop on newly installed filters will be in a range of 1/2 inch to 2 inches of water. That will vary based on your system's design. Factors like air to media ratio, which is the ratio of system airflow to total filter media in the collector, dust loading amount, how much dust is going into your unit, as well as duct design will determine what that looks like for your collector. Once filters enter service, they immediately begin to build a dust cake, and that will increase pressure drop. We typically expect to see stabilized pressure drops on seasoned filters in the range of 2 to 4 inches of water. Again, airflow, dust loading, and dust type will all factor in here. Our recommendation is to begin your cleaning cycle once your delta P reads 4 inches. We then recommend to stop cleaning once they pulse down to 2 inches of water. Again, that's how it looks ideally. Filters don't last forever though. Pressure drop toward the end of a filter's useful life will be in the range of 4 to 6 inches. We recommend changing filters when pressure drop reaches 6 inches and cannot be pulsed down below the 4-inch range. Know that some baghouses are designed to run at higher pressure drops. It's important to understand the relationship between airflow and pressure drop of your specific system. In part of understanding your system, it's important to know what type of collector you have. The two most common types of collectors are cartridge and baghouse, which I'm going to focus on in this session due to time. You may very well have other types in your facility, such as mist collectors for wet machining, fume collectors for applications like ambient weld fume collection, cyclones that are often used as pre-separators or for smaller woodworking applications. Lastly, you might have a power core unit for localized source capture and bin venting. So let's talk about cartridge collectors first. Donaldson actually introduced them in the 1970s, and they have come a long way since then. They are smaller in size and have lower initial cost than traditional baghouses. They provide faster, easier filter changes when the time comes due. They are best for light to medium dust loads. They work best with fine, uniform, and dry dust types, such as those found in fabricated metals, pharmaceuticals, and food processing. Here's some examples of cartridge collectors. As you can see, they vary greatly in terms of size and type. So give me a thumbs up if you have a cartridge collector at your facility. Anyone out there responsible for maintaining a cartridge? There's one. Anyone else? Yep, getting a few more. Okay, good. Yeah, a lot of this presentation will apply directly to the unit you're responsible for. So for those of you who have one or many, they may be located indoors or out. A cartridge collector can be connected to just one machine, or it could be set up to be designed as a centralized system in which is connected to multiple pickup points throughout a plant. So cartridge collectors use cartridge filters. They come in a variety of sizes and shapes depending on the type of collector. In understanding your system, you want to make sure you're using the right filter for the job. There are many different media types for different applications. These examples you see on the screen are just a few of ours just to show you. But it's critical that your system is using the right filter media for your specific application. For one example, if the dust is fibrous, think long and skinny like paper trim or tobacco leaves, the system should be using a filter with open pleat spacing like our fiber web. You can see the second filter from the left. That open pleat spacing allows that stringy dust to be pulsed off. Another example is if dust is agglomerative or it likes to stick together, your system should be using a filter with spun bond, or again, you're going to have issues. If you suspect your cartridge collector could be using the wrong filter media, please reach out. We can help. My contact information will be on one of the final slides. So moving on to the next type of collector I'd like to highlight, baghouse collectors. They have been around for over 100 years. Our baghouses use anywhere from 6 to more than 900 felt or pleated bags to filter dusty air. You might be responsible for maintaining even bigger baghouses. They are best used in applications with higher dust loading, and they are more forgiving on challenging dust types. They're typically much larger in size and require more labor-intensive filter changeouts than a cartridge collector. And here are some different examples of baghouses. Some can be very large. They'll often be outdoors, but smaller units may be found indoors as well. Give me a thumbs up if you have a baghouse collector at your facility. Anyone responsible? Okay, yep, there we go. Oh yeah, handful of people responsible for baghouses. Oh, we got a fire emoji. Their thumbs up. Yeah, a lot of baghouses out there. Excellent. So baghouse collectors use bag filters, and there's two main types. One is fabric bags and the other are pleated bags. Fabric bags are typically 8 to 12 feet in length and are supported by a metal cage. During filter changeouts, the entire bag and cage are removed from the collector, and the used fabric bag is removed from the cage and the new one installed in its place, then goes back into the collector. I'm guessing there are some on the call who are having flashbacks right about now. It's a dirty, cumbersome process, especially for large baghouses. Pleated bags, on the other hand, are a one-piece design. That eliminates the need for a bag and cage. They tend to be shorter in length and take significantly less time to change out. Because the media is pleated like a cartridge, they offer 2 to 4 times the filter media. Not all bag houses can use pleated bags, but they're a great option for certain applications such as abrasive dust. So like cartridge filters, there are many different types of fabric bag media options. It all depends on what your application calls for. If you have moistures or oils in your process, you want to use a filter that is treated to repel them, like our Duralife oleophobic media. Likewise, if you have a high temperature process that would melt a standard polyester bag, you'll need an option similar to Aramid that can handle the heat. If you see that Aramid filter is rated for temperatures over 400 degrees. Again, we offer resources online or via the phone that can assist you in selecting the right one. We can help you verify you have the right filter for the job as well. So I mentioned them earlier, but pleated bags are the other filter option for a baghouse dust collector. If you're looking to solve issues with your baghouse, pleated bags are designed to do just that. They will replace standard fabric bags and cages in your baghouse with no modifications. The benefits of pleated bags are that when applied right, they will eliminate filter abrasion, like if you're having issues with bags tearing. They will lower emissions, who doesn't like cleaner air, safer workplaces. The added filter media will provide longer filter life that offers you fewer filter changeouts and less downtime. Not only will you change them less often, but it takes less time to change them out as well. Lastly, you can turn your pulse pressure down when using pleated bags. This provides energy savings in the form of reduced compressed air usage, generally around 30%. So if your system's running at 100 PSI, you can turn that down to 70 when you make the switch to pleated bags. If you want to optimize the performance of your baghouse, pleated bags are a great way to go. We have resources in place if this is something you're interested in. All right, Taylor, now that we've discussed what good looks like in terms of dust collector system design and how to understand it, do you want to reveal secret number 2?
Yes, thank you, Alex. Secret number 2 is to understand your collector. Now, we might be a little biased, but these pieces of equipment are so much more than just a big blue box. The information you'll need to know includes things like the collector model and size, filter specifics like media type, number of filters, and filter size, the horsepower of the fan, and electrical requirements. If you're not familiar with dust collection systems, it can be a daunting task to even figure out what you have on site. We see this all the time. Customers don't know what type of collector the system components or what they have, so they order the wrong parts, the wrong filters, or the wrong number of filters, the incorrect replacement motor size. We've seen it all. So it's important to understand what you have in your facility. On the next slides, we'll go over a few easy ways to learn more about your collector. A great place to start is to locate the nameplate on your collector. This should usually be found in an easily accessible area. It will tell you important information such as the product name. For this example, this is one of our Downflow Evolution cartridge collectors. It'll say the model number. This one is a DFE 540, which means it has 5 filters high and a total of 40 cartridges inside. It'll have the serial number, which is really important because it will tie it to an order, and it also tells us the customizations that the unit was built with. It will have the electrical requirements, the horsepower of the motor, which both are important for your electrician, and the filter part number that the unit was sold with. And of course, sometimes these get damaged or worn down over time, so it may be difficult to read. If you do need information from the nameplate on yours and you can't read it, please let us know and we'd be happy to point you in the right direction. Oh, and just a heads up, the filter part number can also be found on the filters themselves in some cases. In this case, this is part number P034301, which is a DFE UltraWeb cartridge filter. In many cases, the filter inside could be a little bit different than the one listed on the nameplate. As the process or application changes, the filter does as well. This is a great way to double check and verify what filter you are currently using. We also stamp other information on the filter in case you need it, such as the country of origin and date code. Next, let's talk about secret number 3 to unstoppable performance. This may seem straightforward, but routine preventative maintenance is critical to ensuring system reliability and performance. Now, we're not just talking about changing the filters, which of course is part of a PM schedule, but it's much more than that. We highly recommend that you create a preventative maintenance schedule specific to your process and equipment and stick to it. Preventative maintenance is important for many reasons, including risk management. It can help you identify potential risks to minimize and mitigate them before an event occurs. It is also important in terms of productivity and availability, since routine maintenance will keep your dust collector system working properly, reducing unexpected downtime. It's important from a cost control standpoint as well. Think of preventative maintenance on your dust collector the same as you do your car. You change your oil, you get new windshield wipers, and check the battery, all to keep it running well and longer. This same principle relates to your dust collector. Routine checks and maintenance will extend the life of your investment and keep costs under control. And finally, it's important from a sustainability standpoint. Proper maintenance will impact fans running with efficient electricity usage, effective compressed air consumption, and by achieving energy savings. If you're interested, preventative maintenance schedules are available on our website and vary by collector type. The most common are classified as pulse jet cleaning collectors, but we do have information for non-pulse jet baghouses, intermittent duty collectors, and mist collectors. Alex, if anyone wants a preventative maintenance schedule emailed to them, who should they contact?
Yeah, please send me an email and I'll make sure you get what you need. My email will be listed on the last slide during the Q&A session. So let's play a little game. Please select the emoji that correlates with how often you think each system component should be checked. If you don't know, that's okay, just take a guess. Here's the first one. Differential pressure drop or delta P, how often do you guys think you should be checking this?
All right,
we've got
monthly, weekly, daily. It's more monthlies, more dailies. Dailies. Nice. Alex, you want to tell them the right answer?
Yeah, very good. Thumbs up is the correct answer, daily. So looks like a lot of you got this one, but it is something you want to check every day. Delta P is a quick look at the status of your filters. In some areas, you might be required to record this monthly, weekly, or even daily, depending on the terms of your air permit. With this information, you can track filter performance and anticipate upcoming maintenance needs.
All right, here is the next question. Ductwork. How often should you check the ductwork in your system? This would be like leaks, improper connections of fittings. How often?
All right, people are thinking, okay, looking at monthly, quarterly, weekly, monthly, they're quarterly there, weekly. All right, Taylor, what do you think?
All right, well, the best answer here would be annually. So loose or improper connections can impact the performance of the collection, like loss of suction at the capture points. And it's also important to ensure that conveying velocity in the ductwork is sufficient to prevent dust dropout. Now, I would like to note that NFPA says that depending on your DHA or dust hazard analysis, this might be even more frequent depending on the level of risk with the process. So this is where you can have a conversation with your process owner or authority having jurisdiction, AHJ, to make sure you just kind of go over that DHA and understand it, just because your process might be at an elevated risk. So just keep that in mind. All right, next one. How often should you visually inspect fire and explosion mitigation devices?
All right, annually, weekly. What else are we thinking here? Quarterly? Oh, we've got a daily, quarterly, lots of quarterlies. Monthly, weekly. All right, kind of all over the board, Taylor. What are you thinking?
Yeah, correct answer here would be weekly. It's really important to check all fire and explosion mitigation devices for signs of damage or wear and tear, like the explosion vent or inlet isolation valve shown on the picture every week. Now, the device manufacturer will have a required inspection schedule, and many of these devices will have sensors in place that will alarm if there is an issue, but it's still a really good idea to check for anything obvious, like a tear in the explosion vent from a recent hailstorm or ice storm. Just kind of get in that habit. And if you do notice anything, please contact the device manufacturer immediately and do not attempt to repair it yourself. All right, next one is how often should you check the fan and motor of your system?
Right, monthly, quarterly, lots of monthly, some quarterly mixed in. Right, pretty clear split between monthly and quarterly here. All right, Taylor, what are you thinking?
Yeah, very good. The suggested interval for checking our fans would be quarterly for any wear or imbalances. However, if you do have a custom manufactured fan, it would be best to follow their recommendations, which could be more frequent. And like we alluded to earlier on, listen to how the fan is operating. If you do listen to how the fan is operating, it can give you quick feedback on whether the fan is performing as it should. If you hear anything abnormal, further investigation may be required. All right, the last one is how often should you check the collector's cleaning system? This could be a variety of different types and components, such as the PD pump that generates air for the cleaning on a medium pressure baghouse, as shown on the left, or the diaphragms and solenoids that help produce the cleaning pulses on a pulse jet collector, as shown in the center.
I'm seeing a lot of weekly, monthly. Monthly is probably the top option so far. Some quarterlies. Kind of a split, but looks like we're leaning towards weekly as our answer.
Right, yeah, as they finish coming in, you are all pretty much correct. So this one is weekly, monthly, and quarterly, depending on the type of cleaning system you have. A PD pump on a medium pressure baghouse should be inspected weekly with a more in-depth check every monthly. And that would be including inspecting the filter, oil condition, and belt tension. The diaphragms and solenoids on a pulse jet cleaning collector should be inspected quarterly, but the compressed air supply should be checked monthly to make sure that the regulator is working properly and that there isn't moisture in the system. Well, thank you all very much for your participation with the quiz. That will do it for now. And again, make sure and send Alex an email if you would like a copy of the preventative maintenance schedule for the specific type of collector or collectors in your facility. It can be really confusing what to check and how frequently, but routine preventative maintenance is really important when it comes to making sure your system is performing at its best. Alex, do you want to tell them secret number 4?
Absolutely. Secret number 4 is to understand when to replace wear parts. Donaldson dust collectors are made to last many, many years, but some parts are simply going to wear out. We're here to help when they do. It's important to understand how often wear parts last, how to know when it's time to replace them, where to buy parts, and how to get help when you need it. Next, I'll go into what to look for when it's time to change out important components. So starting with filters, as I mentioned before, once your filters can be pulsed below 4 inches of water, it's time to consider replacing them. You'll notice a loss of airflow at the pickup point. If you don't replace them in short order, you might begin to notice emissions coming from your stack due to complete filter failure, like the filters on the right. This can also result in dust building up inside of your plant due to a decrease in airflow. The next item I'll review are yokes and cartridge collectors in cages and bag houses. They both do their part to support filters in operation. They should be inspected on every filter changeout. If they are rusted, bent, have sharp edges, or are otherwise damaged, it's time to replace them. When they are damaged or out of alignment, they can damage the filters or not allow them to seal properly. They can cause damage to the filters themselves, like you see with that bag with a hole in it on the bottom on the right side of the screen. This will cause issues with dust leaks that you can and absolutely want to avoid. You can see what dust leak looks like in the middle photo on the right. That is a clean air side of a baghouse. There should not be any dust in there. Next up are diaphragm valves, and they are crucial components in your dust collector's cleaning system. They are also wear items. If you stand next to your system while it's operating, the telltale hiss of an air leak is a sign a diaphragm valve likely needs replacement. If it doesn't sound right when it pulses, or if your new filters are having trouble cleaning, it's time to address these components. They are ripped, damaged, or oily. It's time to replace them. Don't address these issues, filters will cease to clean and your delta P will increase in a short amount of time. You'll see an increase in compressed air use and risk the filters collapsing altogether. Avoid these headaches by checking these valves every 12 to 18 months as you notice any signs of issues. Moving on, solenoid valves are another crucial component in your collector's cleaning system. They are what controls your diaphragm valves. If your diaphragm valves are not engaging, the solenoid valves are likely the culprit. You may hear air leaking through the vent port. If you don't change them when needed, you'll experience the same cleaning system failures I just mentioned for diaphragm valves. Your filters will blind over and fail long before they should. Verify these are working every 12 to 18 months as well. Timer and control boards are electronic components that will break down over time as well. If you're having digital display issues, unable to calibrate them properly, or you're experiencing a lack of cleaning, it's time to replace the timer and control board. If these fail, your collector will stop cleaning the filters, and that will leave you with short filter life. Moving on past the cleaning system, another item to check for are gaskets. They are what ensures that dust stays on the dirty side of the collector. You need to inspect them to make sure they rebound properly and don't remain compressed. If any are nicked and torn, it's time to replace them. Dust trails leaking past the gaskets or moisture from the environment making its way into the collector are common issues you'll see. It's important to make sure the gaskets on the filter doors, clean air plenum, and hopper are all in good working condition as well as operating as intended. You want to check gaskets on the doors every filter change and the rest of the gaskets every few years. Explosion vents are another dust collector component that need to be in working order. These can simply wear out over time by being exposed to the elements. Some might bump it by accident and cause a rip or tear as well. If your unit is outdoors, this can allow water to enter the collector. A damaged explosion vent will cause a loss of suction in the collector as no longer airtight. Overall, your dust collector will not perform as needed if these are worn and damaged. They should be inspected weekly. Motors, fan wheels, and the complete fan assembly are what moves the air into your dust collector. It's important to make sure your fan wheel remains balanced and your motor is operating as it should. Verify your motor is not burning out. You also want to make sure the fan housing is in good working order with no leaks or holes due to rust. If you don't replace it, you face reduced airflow, noise, and vibration. All of these things can result in further damage to your fan wheel and housing. Best practice is to monitor your fan exhaust daily and inspect the fan and motor quarterly. So wrapping up here, when you apply the secrets to unstoppable performance, you'll protect your investment in clean air by maximizing the life of your filters. You comply with environmental standards while protecting the health and safety of your employees. Optimizing your dust collector's performance will maintain your system's efficiency while keeping your process up and running by avoiding unplanned downtime. Applying these secrets is your roadmap to success when it comes to operating your dust collector at its peak performance. So we have a lot of resources available for those of you who do your own repairs. If you have questions about parts, please call us at 1-800-365-1331. We have a team of reps who can answer your questions and help make sure you're getting the right parts you needed. If you have questions about filters or need a quote for a filter replacement, please contact your Donaldson filter sales rep. If you don't know who that is, call that 1-800 number on the slide and they will get you connected to the right person. When you want to order parts or filters online, go to shop.donaldson.com. It's quick and easy to use. Many of you, I'm sure, have used it before. So for service, if you simply don't have the time or resources to manage your dust collector's maintenance on your own, we have a service team that's available to help. We get it. Dust collection systems can be difficult to repair if you don't have a lot of experience with them. We have many different service plans available, whether something is broken and you need an immediate fix, you're looking for an annual preventative maintenance visit, or if you want to completely outsource all of your dust collection system maintenance. Either way, our service team is here to help you when you need it. Finding the right filters and parts for your operation can be a time-consuming challenge, especially when every minute counts. Donaldson, we understand the urgency of keeping your operations running smoothly. That's why countless organizations trust us for their filter needs. With over 100,000 filters and replacement parts available immediately, our aftermarket specialists are here to help you find the perfect solution for your equipment. Make it easy to keep your collectors running with inventory available for immediate delivery, expert advice on the best solutions, high quality filters that fit and perform. That's all the content we have for today. We truly do appreciate you guys taking the time to tune in. But next up, we'll start a Q&A session and answer any questions you might have.
All right, great job, and thanks to both Taylor and Alex. So we're going to finish up with some Q&A. Guys, you can go ahead and turn your cameras back on if you'd like to. I'll turn mine back on as well. Sometimes that affects the bandwidth, so we like to keep those off. So just to let you know, we put some different QR codes on the screen. All right, so Alex's email is on there as well. So if you're looking for those preventative maintenance schedules for your facility, if that'd be helpful, please send him an email. He'd love to get those out to you. And again, if you have a service request, questions about filters or parts, the numbers are on the screen. You can snap a photo with your camera if you want to. Anyway, so Alex and Taylor, the first question, this one actually came to me privately. Is it okay to change just one filter out if needed, or should we always change all filters out at the same time? Great question.
I can handle that one. Yeah, it's a good idea to change them all at once. If you replace one filter at a time, unless you happen to get a leak, you just want to change one, okay, go ahead and do it. But generally, if you do go in and just change a few filters at a time, you're going to ruin the life of those filters. Basically, air and dust is going to find the path of least resistance, and that's going to be your clean filters. They're going to plug up and equalize with the other dirty filters in the system. So it's always a good idea to change all of your filters at the same time.
All right, thank you. Next question, how do I check the airflow in my system to make sure it's where it should be?
Yeah, I can tackle that one if you want, Alex. It's a great question. The basics would be like a pitot tube or a manometer. There's also other airflow devices that you can check or use within your duct system if you're comfortable doing that. Otherwise, we have a lot of great territory managers, dealer networks, as well as our industrial services team that would love to come out and help you find that out. They do this very, very often, so they're very well versed in it. And also kind of basing your airflow on the type of dust you're conveying and the type of application you have, they can really kind of help you find out what really works well for your system.
Thank you. Appreciate it. Next question. We're changing cartridge filters about every 3 months. Is that bad? Or maybe
Yeah.
abnormal?
I can handle that one. Yeah, typically, on a normal size system, a lot of our territory managers that sell equipment, they're looking to get you a year of filter life. So if you're changing those out more often, there could be something that's causing that. Sometimes, things change in the plant over time, more drops, more dust is added to the system, and the system just can't keep up. That could be what's going on. It could be moisture getting into the unit, something changed within the process, oils, something like that. So those are things to think about, but ideally you would be getting longer than 3 months of filter life. So I think we can, that's something we could take a look at.
All right. Thank you, Alex. Our next question, what's the approximate cost difference between cartridge and it's filter socks? So I'm like cartridge and baghouse filters. Good question.
Yeah, so cartridge filters contain a lot more media than a standard baghouse or sock filter. They do cost quite a bit more, just based on there's a lot more to them than what a bag filter has. I think maybe the other part of the question, Amy, would be the bags versus pleated bags.
I was just going to ask you to mention that because people always ask us that.
Yep.
What's the price difference between those two as well?
Yeah, pleated bags do cost a decent bit more. It really depends on, I don't even want to give it a number because it depends on so many different factors. What your filter would require. And really it's looking at the ROI of what it's going to help you achieve. If you're changing your dust collector, your bag house out, a couple times a year, and now you're going to change it out 3 times or once every 3 years. Once you switch to pleated bags, that ROI looks a lot more appealing. So it really is situationally dependent, but if that's something you want to look at, we can get you some numbers that are more specifically tailored to your system.
Okay, thank you. Next question, is it okay to wash or manually clean the filters, or does it need to be the collector doing it?
Yeah, I guess we would say definitely recommend not doing it on your own, just because of the very high risk of damage that can happen if you try to do it on your own. Getting compressed air tool far too close to those pleats or other material just has a much higher risk of damage. So our collectors are designed to do a really good job at cleaning those filters themselves, and we typically like to see them do the work instead of maintenance personnel. Just yeah, much higher risk of damage.
Thank you. Next question, what could it mean that we're getting more dust in the air now than we ever have before?
I guess dust in the air, where is it, like in the process? Is it in the discharge of the fan? Did they allude to any of that?
No, if you want to, Andrew, if you want to go ahead and chat in a follow-up statement, question or statement if you want to. So we're wondering where in the air. So it could be the plant air, just in general. That's
Hmm.
kind of what I'm guessing. Okay, so just during production. So in general, there's just more dust in the air than they had before.
Okay, so yeah, maybe something has changed within the process, or kind of like we talked about, it might be something within the collector. You're seeing higher static pressure or reduced airflow, maybe in that system where our capture is not as good as it used to be. So I just kind of review, when you notice that change, did anything change in the process? And then kind of go down the stream. You're like, okay, let's check the filters. What's the static pressure look like? Are we maintaining that airflow in that ductwork to properly capture? Or do we need to relook at sizing the hoods or pickups where those dust generating processes are? I think those are all good places to start, especially if it's just in the process or the production facility, not discharge. Hopefully that makes sense.
Yeah, I'd take a look at the Delta P to see where the filters are at first off on that, just to make sure, if the filters are dirty and they're plugged, it could be time to change those out, and that'll restore your airflow. Could be simple as that, but otherwise it could lead into all those things that Taylor just mentioned.
Yeah, and I would say if you need help with that, if you reach out to one of these, I guess service providers or your local church room manager, they would love to come in and help, just see what's going on and maybe help troubleshoot those in person. I feel like it's always easier to do when they're at the site, but we are also happy to help over the phone if you need to as well. If you gotta contact us after the fact too.
All right, so our next question, how should you sequence pulse jets and what should be the off time for a cartridge style dust collector? Great question.
I guess I can go with that one. Usually our pulse jet collectors will have a sequence kind of pre-wired, or the collector should have been sold with a sheet that kind of shows the sequence of what like the pulsing diaphragms are going to be. Usually it starts at the top and works its way down to kind of help gravity bring that dust down. The standard set point for our pulse time off is 10 seconds. And that's really just to help that compressed air manifold regenerate the air needed for a good pulse. Now, if you have a constant cleaning collector where it's always running, it's just going to pulse every 10 seconds, regardless of the differential pressure across the collector. If you have a delta P or delta P plus, that will go based on the differential pressure as well, like a set point. So our standard would be 2 inches for low, 4 inches for a high. And it's going to start cleaning once it reaches 4, and it's going to pulse until it gets down to 2. So it kind of depends on your process. Yeah, just kind of ranges depending on what kind of dust you have, where you set those points. But I would say typically to follow that recommended setup, it's pulsing from the top down and then leaving the set points at in between that like 10-second mark is helpful just because it gets that pressure where it should be.
So Taylor, just to follow up with that, if it's set too frequently, what happens? Like, what are the ramifications of, let's say it's set to 5 seconds or something that's too frequent?
Yeah, one, you're going to see a lot more compressed air usage, and you likely, unless you have an amazing compressed air system, you're likely going to see weaker pulses. So you're just having a less efficient cleaning cycle, and your compressed air or compressor is just working far harder than it should to kind of maintain that. So just something to, yeah, make sure you kind of check and um, yeah, make sure that it's pulsing at the right frequencies, and you'll know because yeah, it does cost a lot if it's constantly pulsing, especially at 5 seconds apart.
Right. It probably can't even get to the right PSI at that point, right? Probably can't even charge
Right.
that. So that makes
Yeah.
sense. All right. Thank you. That was our last question. We'll stay on for maybe another minute or two in case anyone else had an additional question. But thanks to everyone for joining us today. Great job to both Alex and Taylor. Great information, you guys. And we'll make sure that since some people ask us if they can get a copy of the presentation, we'll make sure that this recording is posted on our on-demand webinar page. And if you'd like, oh, the QR code on that is on the screen. Otherwise, Alex can also send you in the right direction if that's something you'd like to look at. Well, that should be available probably in about a week. We need a little bit of time to post it up there. So that looks like that's all we have. Great job, everybody. Thanks for your time today. We appreciate it. And have a great rest of your day.
Thank you all for joining.
Thank
Been a
you.
pleasure.
Hey, Alex and Taylor,
Mhm.
we had one more question. Are you able to stay on for just a few more seconds?
Oh, yep.
Did I catch you in time? Okay, how long should the cleaning cycle last at the end of the day? Ours goes for 2.5 hours. Hopefully Kevin's still on who asked that question. How long should it last at the end of the day? So if they're doing a cleaning cycle at the end of the day.
I think that depends mostly on how much, how plugged your filters are and what you want your starting differential pressure to be in the morning. I'm assuming this is like a downtime cleaning, you know, the fan's not running.
Yeah.
But yeah, that seems a little long to me. Taylor, I don't know what to recommend. I think is it like 15 minutes our normal delta P is set for when it downtime cleans?
I believe so, somewhere around that, yeah, for a downtime clean. And like you said or alluded to, it kind of depends on the process and what your differential pressure is currently running at and what you want it to start to. Like I've heard of people kind of configuring larger bag houses to run quite a while just to kind of make sure that with the fan off and everything, the filters are effectively cleaned. So I think that could swing to get into a little bit longer downtime cleaning process, but it does seem long to me if it's just like a cartridge or pulse jet collector to continually go through that.
I would think you could work that back, Kevin, and see, you know, hey, cut it to 2 hours and see what your differential pressure is the next day. Following day, cut it to an hour and a half. And just kind of work it backwards that way. You could probably dial in what makes sense for you in about a week with a little attention to that.
Yeah.
Awesome. Thanks, you guys. Appreciate it.